Welcome to lecture number 16 of fuzzy sets, logic and systems and applications. So, here we are in the continuation of properties of classical and fuzzy sets, where we have seen that the properties listed here all are holding good for classical sets, whereas we are here seeing that some of the properties like law of contradiction, law of excluded middle, absorption of complement, these three properties out of all mentioned here are not holding good for fuzzy sets. So far we have covered law of contradiction, law of excluded middle, idempotency property, involution, commutativity, associativity, distributivity, absorption of complement. So, in the continuation in this lecture today, we will discuss De Morgan's law with respect to fuzzy sets, and when we see De Morgan's law of union is defined here for crisp sets A and B as, when we take the complement of A union B, this is going to be the intersection of A complement and B complement. So, this is holding good for crisp sets, we all know. Let us see if we take fuzzy sets, whether the De Morgan's law of union holds good for fuzzy sets or not. Yes, it holds good for fuzzy sets as well. So, if we take two fuzzy sets A and B, and we take the complement of A union B, we are going to get, or we are getting the fuzzy set which is complement A intersection complement B. So, De Morgan's law for fuzzy sets also hold good. So, let us now understand De Morgan's law for fuzzy sets better by taking couple of examples. So, here we have example which has two fuzzy sets A and B, two continuous fuzzy sets A and B. A is here and B is here. So, let us now take the complement of A union B, which is mentioned over here, and then let us see whether this is equal to or this is exactly same as the intersection of A complement and B complement. So, we first find the A union B. So, since A is here, B is here, fuzzy set A, fuzzy set B, let us find A union B. So, to find A union B, we know we superimpose these two fuzzy sets on each other and we apply Max criteria, and when we apply Max criteria, we get A union B as a result here. So, this is A union B. Now, we have to find the complement of this fuzzy set, which will be the complement of A union B. So, let us see how does it look like. So, when we have complement of A union B, we just subtract this, we apply the criteria mentioned here, we subtract this from 1. So, we apply for getting A the complement of A union B, we get 1 minus max of all the corresponding values of membership functions of A and membership function of fuzzy set B, for respective generic variable values in the universe of discourse of course. So, we see that we have the complement of A union B like this. Now, let us find out the A complement here, A complement here and B complement here. Let us find out from these two fuzzy sets and see what are we going to get when we take the intersection of these two fuzzy sets. So, A complement is here, is A complement of A, I mean complement of A, and then complement of B, that is B complement, which is here. So, B complement, this is A complement. We are interested in finding the intersection of these two complements, and let us see what are we going to get when we take the intersection of these two. So, we superimpose these two fuzzy sets on each other here as we have done, and since we are taking intersection, when we apply min criteria, we are going to get here this fuzzy set as the outcome. So, we clearly see here that when we take the complement of A union B and when we take intersection of A complement and B complement, we see that these two are same. So, this way we can, since the outcomes, both the outcomes are equal. So, we can say that De Morgan's law of union holds good for fuzzy sets A and B, and that is how this relation is valid for fuzzy sets. Now, let us take an example here with discrete fuzzy sets and see what is happening. So, here also when we take fuzzy set A and fuzzy set B, and these two fuzzy sets are discrete fuzzy sets, and when we compute the complement of A union B as it is shown here, A union B, the complement of A union B, we are getting the fuzzy set 0.2 oblique 1 plus 0.5 oblique 2 plus 0.3 oblique 3 plus 0.4 oblique 4 as a result. And when we find the intersection of complement of A and B and complement of B, so we find here as a result 0.2 oblique 1 plus 0.5 oblique 2 plus 0.3 oblique 3 plus 0.4 oblique 4. So, we see that if we take this as the outcome here of the complement of A union B, and we see that this is exactly equal to the same as when we take the intersection of A complement and B complement. So, we see that the De Morgan's law of union here also is valid when we take the discrete fuzzy sets A and B. Now, let us, so earlier what we were seeing was the De Morgan's law of union, and this we verified by taking examples of fuzzy sets A and B. Now, we are extending this to 3 fuzzy sets. So, we all know that for crisp sets also, when we take the complement of A union B union C, this is equal to the A complement intersection B complement intersection C complement. So, this is same as when we use instead of crisp set, we take fuzzy sets A, B and C. We see that the De Morgan's law of union is valid here or holds good here So, in other words we can say for fuzzy sets A, B, C, when we take the complement of A union B union C is equal to the A complement intersection B complement intersection C complement. So, these two are valid. So, this is valid for crisp here, means the De Morgan's law of union is valid for crisp as well as fuzzy sets. When we take more than 2 fuzzy sets, for 2 fuzzy sets we have already seen. So, when we increase the number of fuzzy sets, here also this is valid. So, let us now take an example and understand better. So, see here we have A fuzzy set, B fuzzy set and C fuzzy sets, and let us now take the complement of A union B union C. So, for getting this we superimpose these ABC fuzzy sets on each other, and when we have done this we see that this looks like this. So, we have to apply the max criteria, and when we apply max criteria we are going to get this as, which is shown by the red color. So, this is A union B union C. Now, when we take the complement of this, so this is exactly the A union B union C, and when we take the complement of this we are going to get this as the fuzzy set. Now, let us take the intersection of A, B and C. So, we have A here as fuzzy set, B is C. So, let us take the intersection of A complement. So, A complement we see here, this is A complement, and then we have B complement, and then we have here C complement. So, now we are interested in finding the intersection of these complements. Let us superimpose these 3 complements on each other, which is here, and since we are interested in intersection, we have to apply the min criteria. When we apply min criteria, we see the result which is shown by red color, which is here. So, we see here very clearly that these 2 outcomes are equal, means when we take the complement of A union B union C, and this is equal to the intersection of A complement, B complement and C complement. So, this way we can say that De Morgan's law of union is holding good for fuzzy sets A, B and C. Now, the same can be checked by taking 3 discrete fuzzy sets A, B and C. So, let us now see what is happening when we take 3 discrete fuzzy sets. So, let me just write it, just represent this fuzzy set by 1 here, and then by 2 here, is by 3 here. So, these 3 are 3 discrete fuzzy sets, and we are interested in the complement of A union B union C first. So, when we find this as this is mentioned here. So, A, the complement of A union B union C, we are getting 0.2 oblique 1 plus 0.3 oblique 2 plus 0.3 oblique 3 plus 0.1 oblique 4. So, this is what is the discrete fuzzy set which is outcome of the complement of A union B union C. Now, let us find out the intersection of A complement, B complement, C complement. So, first we need to find out the A complement. So, this is A complement, then this is our B complement and this is our C complement. So, these three are the fuzzy sets or the complements of A fuzzy set, B fuzzy set, C fuzzy set respectively. Now, if we take their intersection means the intersection of A complement, B complement and C complement. So, means we have three fuzzy sets, these three fuzzy sets are complements of A, B and C separately, and when we take intersection, we of course, we apply the mean criteria, and then when we apply mean criteria, we are getting a fuzzy set which is a discrete fuzzy set, and this is 0.2 oblique 1 plus 0.3 oblique 2 plus 0.3 oblique 3 plus 0.1 oblique 4. And when we see this fuzzy set is exactly same as we have got here. So, this fuzzy set is same as the fuzzy set which we have got out of the complement of A union B union C. So, this way we can say that the De Morgan's law of union for discrete fuzzy set A, B and C is holding good. So, first when we take crisp fuzzy sets, we all know that De Morgan's law of intersection is valid, holding good, and when we take fuzzy sets A and B, here also this is holding good, means this is valid. So, when we take the complement of A intersection B, this will be equal to the union of A complement and B complement. So, this is called the De Morgan's law of intersection, and let us now understand this better by taking couple of examples. So, first we will take two fuzzy sets A and B here. We have A here, A fuzzy set here and B fuzzy set here, and let us see how this De Morgan's law of intersection is holding good. So, to check that, let us first find the complement of A intersection B. So, here first find the A intersection B. So, let us first superimpose A and B on each other as it is shown here, and then since we are taking the intersection, of course, we will be applying the mean criteria, and then we see here we are getting this fuzzy set as A intersection B. Now, let us take the complement of this outcome. Let us take the complement of A intersection B. So, let us see what are we going to get. We have to subtract the respective membership values from 1, and if we do that, we are going to get this fuzzy set as the complement of A intersection B. Now, let us find the A complement and B complement and then take their union, and let us see whether this is equal to the complement of A intersection B or not. So, let us now start. So, A fuzzy set is here and B fuzzy set is here. Let us take the A complement. Let us get the A complement. A complement is here, this is A complement, and B complement is here. Now, we are interested in union of A complement B complement. It means we have to superimpose A complement and B complement on each other like this, and then since we are interested in the union, we have to apply the max criteria, and when we apply max criteria, we are going to get here this as the outcome. So, this is the outcome of the union of A complement and B complement, and if we see, it is very clear that these two outcomes are same. So, what does this mean? This means that the complement of A intersection B is equal to the union of A complement and B complement. So, this way you see here we can say that the De Morgan's law of intersection holds good for continuous fuzzy sets. Now, let us check the same for discrete fuzzy sets. So, we see here if we take two fuzzy sets A and B, and we see that we have on the same lines as we have done in the previous example, we take the complement of A intersection B. So, A intersection B is here, complement of A intersection B. So, this is coming out as 0.3 oblique 1 plus 0.7 oblique 2 plus 0.9 oblique 2 plus 3 plus 0.5 oblique 4. So, this is what we are getting as the fuzzy set, discrete fuzzy set, which is coming as the outcome when we take the complement of A intersection B. Now, let us take the union of the complements of A and B. So, we have A complement here, B complement here, and I can show it like this by this arrow, A complement, B complement, and when we take union of these two fuzzy sets, when we take union of these two fuzzy sets, so we see that we are getting 0.3 oblique 1 plus 0.7 oblique 2 plus 0.9 oblique 3 plus 0.5 oblique 4. If we see here, this outcome is same as the outcome of the complement of A intersection B. Now, if we take more than two fuzzy sets, so let us see what is happening. Of course, here also the De Morgan's law of intersection is holding good. So, and if we talk of crisp sets A and B, A, B and C, these crisp sets, the De Morgan's law of intersection is satisfied. So, we do not have to care about crisp sets, because when we for crisp sets, when we see the De Morgan's law of intersection, this is valid. So, this valid, when we say valid, valid means when we take the complement of A intersection B intersection C, this is equal to the union of A complement, B complement and C complement. So, this is valid for crisp sets, and when we take fuzzy sets A, B and C, here also this is valid. This De Morgan's law of intersection is valid. So, this means that if we have A fuzzy set, B fuzzy set, C fuzzy set, and if we take the complement of A intersection B intersection C, this is going to be same as the complement of A union complement of B union complement of C, and this is called the De Morgan's law of intersection, as I just mentioned. So, let us now understand this also better by taking one example here, and here we take again same as other examples, we take the three fuzzy sets A and B, A, B and C fuzzy sets. These fuzzy sets are continuous fuzzy sets. So, here this A fuzzy set, A continuous fuzzy set, B continuous fuzzy set and C continuous fuzzy sets. A is triangular, B is Gaussian fuzzy set and C is a trapezoidal fuzzy set. So, our intention now is to find the complement of A intersection B intersection C. How do we get that? So, for getting this, first we have to find A intersection B intersection C, and then we take the complement of the outcome. So, if we have A here, A fuzzy set here, B fuzzy set here, C fuzzy set here, we can superimpose these three fuzzy sets on each other, which is here and which is shown here, and then apply the min criteria. And when we apply min criteria, we get here a fuzzy set as the outcome. So, this is nothing but the intersection of A, B and C fuzzy sets. Now, we are interested in complement of it. So, we have to take the complement. When we take the complement, we are going to subtract all respective values of membership values, all respective membership values from 1. So, when we do that, we are going to get this fuzzy set as the outcome. So, this is nothing but the complement of A intersection B intersection C. Now, let us find out the union of A complement, B complement and C complement. So, here we have A complement, which we have got from the fuzzy set A. So, we have A complement here, and then let us find B complement. So, B complement is here. We already know as to how we can find the complements. We subtract the respective membership values from 1 throughout the universe of discourse. We get the complement, and so when we have B complement, now we see C complement. So, C complement is here. Now, we have A complement, we have B complement, we have C complement. We are interested in their union. So, let us find the union of these three complements. How do we do that? So, we superimpose each of these complements, each of these fuzzy sets, the complement fuzzy sets on each other, and since we are interested in the union, we apply the max criteria. So, we can clearly see here that in this plot here we have superimposed all the three complements, and then when we apply the max criteria, we find the fuzzy set which is mentioned by, which is denoted by the red color, which is shown in red color. So, what we are getting here as the outcome of the union of A complement, B complement and C complement, we see that this is exactly the same as what we have got. This is a fuzzy set exactly same as what we have got when we have taken the complement of A intersection B intersection C. So, this way we can say, since the outcome is equal here for the continuous case, when we have taken three fuzzy sets, the continuous fuzzy sets, we can say that the De Morgan's law of intersection is holding good for continuous fuzzy sets. So, in other words, I can repeat here, in other words we can say that if we have to find the union of the complements of A, B and C, we can do this, we can find this by simply taking the complement of A intersection B intersection C, or in other words again A intersection B intersection C complement is equal to A complement union B complement union C complement. So, either way we can say. Now, the same can be checked with 3 discrete fuzzy sets. So, we have taken here 3 discrete fuzzy sets. This first fuzzy set, this second fuzzy set is 3, this is third discrete fuzzy set. So, De Morgan's law of intersection, let us now try to see what is happening when we take these 3 discrete fuzzy sets and see whether the De Morgan's law of intersection is holding good or not. So, for this we have to first find the complement of A intersection B intersection C. So, when we see that, what we are getting here is 0.6 oblique 1 plus 0.7 oblique 2 plus 0.9 oblique 3 plus 0.5 oblique 4 here. So, I can repeat the outcome here. Complement of A intersection B intersection C is coming out to be 0.6 oblique 1 plus 0.7 oblique 2 plus 0.9 oblique 3 plus 0.5 oblique 4. Now, let us take the union of A complement, B complement and C complement. So, when we take this union, we see that we are getting here as the 0.6 oblique 1 plus 0.7 oblique 2 plus 0.9 oblique 3 plus 0.5 oblique 4. So, if we compare this discrete fuzzy set with this fuzzy set. So, we see that this is same as these 2 fuzzy sets are same as they both are same, they both are, these 2 fuzzy sets are equal. So, we can write here this fuzzy set is equal, means the union of A complement, B complement and C complement is equal to the complement of A intersection B intersection C. So, we can clearly say that the De Morgan's law of intersection is holding good for discrete fuzzy sets A, B and C. So, this way we have seen that the De Morgan's law is very much holding good for fuzzy sets as well. Now, let us go through all the properties of sets once again. So, we have a table here, and in the first column we have listed all the properties, and then in the second column we have the classical sets, third column we have fuzzy sets. So, this way we can say that out of all these properties that are listed here for classical sets and fuzzy sets, only 3, namely law of contradiction, law of excluded middle and absorption of complement, these 3 they behave differently for classical sets and fuzzy sets. Rest all others are same as, I mean in both the cases for classical set and fuzzy sets they behave the same, means they are holding, they are valid for classical sets and fuzzy sets. So, with this I stop here, and in the next lecture we will discuss the concept of fuzzy distance. Thank you.